When, in 2023, the James Webb Space Telescope turned its powerful instruments toward the exoplanet K218b, located about 120 light-years away from Earth, it made one of the most intriguing discoveries of its scientific career. The observation revealed the presence of dimethyl sulfide, DMS, in the atmosphere of this distant world, a molecule that, on Earth, is exclusively produced by living organisms such as algae and marine phytoplankton. This chemical compound is of great interest to scientists because, on our planet, its presence is closely linked to biological processes. Although this discovery initially sparked a wave of excitement, the real question remains: could this be concrete evidence of extraterrestrial life? Or is it simply a cosmic phenomenon that can be explained in other ways? The detection of DMS in the atmosphere of K218b was a moment of great excitement for astronomers. Indeed, the presence of a molecule associated with life is one of the clearest signals that could confirm the existence of life forms beyond Earth. Astronomers were immediately confronted with a crucial question. If DMS is exclusively produced by biological organisms on Earth, could its presence on another planet truly suggest the existence of life? However, despite the excitement, there is an awareness among scientists. The detection of DMS does not necessarily imply proof of life, and every step must be evaluated with extreme caution. The presence of this molecule, while fascinating, could also have other explanations that do not involve life forms, such as chemical or geological processes. In fact, DMS is known to be produced by marine organisms, particularly algae and phytoplankton that thrive in the oceans. These algae release DMS into the atmosphere when exposed to sunlight or through decomposition processes. The result of this biological activity is the typical odor we often associate with coastal areas or beaches, produced by the decay of marine organisms. Thus, while DMS is an unmistakable sign of biological activity on Earth, the idea that a similar molecule could exist on an exoplanet raises more complex questions. Its presence on K218b could be evidence of extraterrestrial life, or simply the result of a purely natural, non-biological chemical phenomenon. This very aspect has fueled debate among experts. K218b, in fact, is not just any planet. It lies in the habitable zone of its star, K21, a red dwarf that, although much cooler than our Sun, emits just the right amount of radiation to allow a planet to host liquid water on its surface, an essential ingredient for life as we know it. At first glance, K218b would seem like an ideal planet for hosting life forms similar to those on Earth. It is a water world, covered by oceans, and was first charted in 2015 thanks to data collected by the Kepler Space Telescope. Located at a distance of about 0.14 astronomical units from its parent star, K218b completes an orbit in just 33 days, a time period that provides precise indications that its climatic conditions might be very similar to those on Earth, at least in terms of the solar radiation it receives. The detection of methane and carbon dioxide in K218b's atmosphere, along with the absence of ammonia, further suggests that this planet could be similar to Neptune, but with a surface covered by liquid oceans, a type of environment that might support life. However, these same chemical signals also introduce complications. DMS, while a potential sign of life, is not easy to identify definitively. The data collected by James Webb has been thoroughly processed, but the signature of DMS was detected within a wavelength that overlaps with methane, making it difficult to distinguish between the two compounds. This does not mean that the research has reached a dead end, but rather that the astronomers' work is far from finished. Despite the difficulties, there are still possibilities to solve the mystery. The analysis of the data collected by James Webb is a delicate and lengthy process, and researchers do not expect to obtain definitive answers immediately. However, there is good news. Scientists are continuing to work on analyzing the data, and while the final results will take time, the work is already well underway. Additionally, theoretical techniques exist that can help better understand the data before concrete results are confirmed. For example, scientists are using chemical models to simulate the atmospheric and oceanic conditions of K218b, attempting to understand how DMS might accumulate in the atmosphere and what quantity would be necessary for it to be detected by telescopes. Experts at the University of California, Riverside, for example, have reconstructed the environment of K218b using theoretical models that simulate the behavior of water and the atmosphere on this planet. In this way, they have estimated how much DMS would need to be produced by potential living organisms to accumulate in concentrations sufficient to be detected. The good news is that, theoretically, it would be possible to detect gases such as DMS on hydrogen-rich aquatic worlds like K218b. However, this is only valid if extraterrestrial organisms producing DMS are particularly prolific. In fact, DMS production on K218b would need to be at least 20 times greater than that on Earth to be detected with our current instruments, a consideration that could further complicate the interpretation of the data. The mystery of DMS on K218b thus remains shrouded in doubt, but the possibility that this signal indicates the presence of extraterrestrial life cannot be dismissed. Whatever the truth may be, the discovery is nonetheless a fundamental step in the search for life beyond Earth. If, in the end, we are able to unequivocally identify DMS as a sign of life on K218b, it would be one of the most revolutionary discoveries in the history of space exploration. For now, scientists around the world continue to monitor the data, striving to solve the mystery of this exoplanet and its potential life forms. The confirmation of DMS would indeed be a milestone in our understanding of the cosmos and might finally answer one of humanity's oldest questions: are we alone in the universe? Although we cannot yet say for certain, K218b may be one of the most promising places to seek an answer. The work continues, and every new piece of data could bring us closer to the truth. If you enjoyed this in-depth exploration and would like to support our channel, don't forget to leave a like and subscribe. Your support is essential to help us continue exploring and sharing extraordinary discoveries like this one. Thank you for your interest and attention, and let's keep searching for the truth together.